By 1944, German engineers were desperate. The Reich was losing ground on every front. Weapons meant to turn. The war had not arrived. Men fought in rubble. They died clearing rooms. Standard rifles could not cover. Military regulations were clear. Infantry weapons were to be operated as designed. Unauthorized modifications were forbidden. Getting caught meant confiscation, reprimand, or a punishment detail. But regulations, written in offices, rarely survived the front lines. Men in basements and shattered streets needed to shoot around walls without exposure. Some units bent the rules before the barrel was even bent. Others attached what they were not supposed to. A few improvised what the Reich never sanctioned. All of them were trying to survive. These are the 10 curved barrel variants German soldiers used anyway. Number 1, the Krummlauf, the original bent barrel. The Krummlauf was a barrel attachment designed for the Sturmgewehr 44. It used a curved steel tube fitted to the muzzle of the rifle, redirecting the bullet's path through a bent section. A periscope sight mounted above allowed the operator to aim without exposing themselves. The device was produced in two angles, a 30-degree bend and a 45-degree bend. A 90-degree version was tested but never issued. The attachment was designed and produced by Rheinmetall Borsig. Military regulations required all weapon modifications to receive official ordnance approval. The Krummlauf was the exception. It was the officially sanctioned version. The problem was supply. Fewer than 10,000 units were produced. Most units never received one. Soldiers needed to shoot around corners in urban combat. The standard rifle required the shooter to expose their torso or head. In street fighting, that exposure was often fatal. Some soldiers used early prototype units, stripped from damaged equipment. Others requested transfers to units that had received Krummlauf allocations. A few carried bent barrel attachments reverse-engineered from diagrams circulating through engineering battalions. Units in Berlin's defense received priority allocation of the 30-degree variant. Pioneer battalions used the 45-degree model for bunker and trench clearance. The barrel bent the bullet, but it wore out fast. The curved section cracked after 300 rounds on the 30-degree version and fewer than 160 on the 45-degree model. Replacement parts were not available at the front. When the barrel failed, the attachment became dead weight. War does not always provide the tools it demands. Sometimes it provides the idea of a tool, and soldiers make do with what they have left. Number 2, the 30-degree infantry version. The 30-degree Krummlauf variant was the most widely distributed model. It attached to the standard STG-44 muzzle and deflected fire to the right or left of cover without requiring the operator to break their concealed position. The sight used a series of prisms to give the shooter a line of view matching the barrel's deflection. It weighed approximately 1.5 kilograms when attached. Regulations restricted use to trained personnel who had completed a short course on the attachment's operation and maintenance. Most frontline soldiers received no such training. Urban combat in 1944 and 1945 did not allow for training schedules. Men who received the equipment learned by doing. Often during the engagements it was intended for. Some soldiers removed the prism sight because it added weight and was difficult to use under stress. Others modified the mounting clamp to accept improvised wire brace supports after the standard clamp worked loose during firing. A few units shared a single attachment across a 4-man fire team, passing it down the line as needed. The soldiers in Aachen and Budapest reported attaching the 30-degree unit to carbines, which was not designed or authorized. Pioneer units used it for clearing cellars where full weapon exposure was impossible. The prism sight fogged in cold weather. Without it, the shooter had no reliable way to aim through the bent section. Rounds fired, blind, went wide. In a basement, a miss in the wrong direction was as dangerous to the shooter's own side as to the enemy. A tool used without its manual is still a tool. Whether it works depends on the man holding it. Number 3. The 45-degree Panzer version. The 45-degree Krummlauf variant was designed specifically for armored vehicles. Tank crews could mount it inside the hull of a Panzer IV or similar vehicle and fire through ports without opening hatches. The sharper bend allowed coverage of the blind spot directly beneath the hull. Rheinmetall produced a specialized mount for this version that attached to the existing hull port ring. Regulations required vehicle crews to use authorized closed defense weapons only. The Kugelblende ball mount was the standard issue for close-range hull defense. The Krummlauf Panzer version was an additional system, not a replacement. Tank crews in close urban fighting found the Kugelblende provided insufficient coverage of angles directly beside the vehicle. Infantry climbing onto a tank from below were nearly impossible to engage through standard hull ports. Some crews mounted the 45-degree unit themselves using welded improvised brackets when factory mounts were unavailable. Others used sections of flexible conduit to extend the attachment's reach inside the fighting compartment. A few removed the Panzer-specific mount and adapted the attachment for use on foot with a field-modified carbine stock. Crews in Warsaw and Breslau stripped Krummlauf units from disabled vehicles and carried them on foot during withdrawal. One documented account from a Waffen-SS unit describes 2 soldiers operating the attachment cooperatively, one aiming through the prism, one holding the weapon steady. The 45-degree bend put extreme stress on the barrel at the curve point. Rounds did not always exit cleanly. Barrel splits occurred without warning, and the failure could redirect fragments back toward the operator. Machinery built past its limits eventually declares that fact in one moment. Number 4. The periscope rifle, infantry, improvisation. Before the Krummlauf reached the front, soldiers improvised their own angled fire systems. The most common method was attaching a bent metal tube or angled mirror assembly to a standard carabiner 98K. These were not factory built. They were made by unit armorers, field engineers, or individual soldiers using available materials. Regulations did not cover these constructions because they had no official category. Technically, they violated the rule against unauthorized modification of service weapons. Men in trenches and cellars could not wait for issued equipment. If they could build something that allowed them to fire without dying, they built it. Some soldiers bent sections of drainage pipe to approximate the Krummlauf's angle and wired them to the barrel. Others used 2 pieces of angled metal stock welded at the midpoint with a drilled channel for the round. A few attached mirror assemblies from periscopic trench viewers to their sights, giving them a view over cover without a bent barrel. Units in Italy documented a version using a curved automobile exhaust section from a destroyed vehicle. Field armorers in Stalingrad-era accounts describe building angled fire tubes from shell casings soldered together. The improvised tubes could not handle sustained fire. The solder joints failed. The welding cracked. The mirror fogged or broke. A weapon that worked for one engagement might not work for the next. What soldiers built in the field reflected what the system failed to provide in time. Number 5. The experimental 90-degree version. The 90-degree Krummlauf was tested at the Hillersleben Proving Ground in 1944. It was designed to fire directly downward from an aircraft or from elevated positions where conventional fire was impossible. The bend was complete, a right angle. Rounds fired through it experienced extreme drag and pressure variation. The project was assigned to a small Rheinmetall engineering team working under Wehrmacht ordnance oversight. This version was never approved for field issue. The testing protocols required 3 successful firing sequences before any weapons system advanced to limited production review. The tests were ordered because High Command believed paratrooper and airborne suppression required new solutions. Engineers followed orders. Some test personnel modified the feed mechanism to reduce the cyclic rate, trying to lower pressure on the curved section. Others tested different powder charges to reduce peak barrel pressure at the bend point. A few engineers submitted written proposals to abandon the 90-degree model entirely and focus resources on the 45-degree variant. One account from the Hillersleben records describes a test firing in which the barrel fractured on the 3rd round, destroying the attachment and damaging the host weapon. The team replaced the fractured section and continued testing. The barrel split at the curve point on repeated firing cycles. At 90 degrees, the forces acting on the round during deflection exceeded the material tolerance of the steel used. No alloy available to the program solved the problem within the development timeline. Some problems are not engineering failures. They are physics refusing to negotiate. Number 6. The sniper scope adaptation. Some units attempted to adapt the Krumm-Lauf principle to sniper rifles. The goal was to allow a sniper to fire from a concealed position without exposing enough of their profile to be detected. The primary weapon used in these experiments was the Gewehr 43, a semi-automatic rifle already fitted for optics. The curved attachment was modified to accept the Gewehr 43's muzzle threading. Sniper doctrine prohibited field modification of precision weapons. Any change to the barrel or muzzle affected accuracy beyond acceptable tolerances. Frontline snipers disagreed. In urban fighting, a sniper who had to fully expose to fire was a sniper with a shortened career. Some snipers removed the optical scope entirely when using the bent attachment, relying on the periscopic sight only. Others retained the scope and used it for initial target acquisition before switching to the periscopic view for the actual shot. A few units designated one rifleman per sniper pair specifically to operate the Krummlauf, while the primary sniper directed targeting. Accounts from Königsberg describe a 2-man team using this method to engage Soviet machine gun positions behind rubble barriers for 3 consecutive days. Snipers in Vienna reported attaching the unit to a captured Soviet weapon after their own rifle was damaged. Accuracy at range through the bent section was poor. The rifling imparted spin, but The deflection disrupted stabilization. Effective range dropped to under 50 meters. At that distance, the weapon worked. Past it, rounds tumbled. Precision and improvisation rarely share the same tolerances. Number 7. The Fallschirmjäger field variant. German paratroopers carried the Krummellauf in limited numbers during late war defensive operations. Fallschirmjäger units were among the first to receive the 30-degree version. In the field, they modified the attachment further. The standard mounting clamp was replaced by paratrooper armorers with a lighter friction lock system salvaged from signal equipment. This reduced the attachment weight by roughly 200 grams, significant for units moving on foot. Fallschirmjäger regulations permitted unit-level armorer modification if the change did not compromise weapon function. The friction lock substitution was borderline. Paratroopers operating in Italy and the Ardennes were moving constantly. Every gram removed from equipment was a gram that did not slow a man down. Some units attached the modified Krummellauf to the FG-42, the paratrooper's automatic rifle, rather than the STG-44 it was designed for. The muzzle diameters were close, but not identical. Field armorers shimmed the gap with wrapped wire. Others used the attachment without the periscopic sight, firing by sound and direction, in close-range cellar fighting where accuracy mattered less than volume. A few paratroopers removed the internal deflector plate from the curved section to increase round velocity at the cost of added barrel wear. Squads in Monte Cassino accounts describe passing a single Krummellauf attachment between fighting positions along a ridgeline, detaching and reattaching under fire. The friction lock mounting worked loose during sustained fire. The attachment shifted, and subsequent rounds hit the inside of the tube rather than exiting cleanly. Jams followed. Soldiers simplify equipment because the field demands it. The field then demonstrates why the original specification existed. Number 8. The bunker clearance version. Pioneer battalions adapted the Krummellauf for a specific problem: clearing fortified rooms and bunkers where a grenade could not be thrown and a standard rifle barrel could not be aimed through the firing port. The version they used was a field-assembled combination of the 45-degree attachment with an extended barrel spacer, allowing the weapon to be inserted partially through a firing slit and discharged into the interior. Assault engineer doctrine required the use of specialized breaching charges or flamethrowers for fortification clearance. The Krummellauf combination was not in any standard Pioneer manual. Fortifications in 1944 and 1945 were not always cleared according to manuals. Pioneers needed options. Some Pioneer teams removed the periscopic sight entirely for this application, firing blind through the port and relying on volume to suppress. Others fabricated a bent wire guide that extended from the barrel tip to help position the attachment within the firing slit before insertion. A few units used a two-man method where one soldier held the weapon through the port while a second operated the trigger via an extended cable mechanism built from radio wire and a modified trigger guard. Documented accounts from the Siegfried line describe pioneers using this method against pillboxes where standard demolition charges had failed to produce collapse. One engineer battalion report from the Rhine crossings describes clearing 4 fortified positions in a single day using the field-assembled system. The barrel inserted into a firing port absorbed return fire from the defenders inside. The metal was not thick enough. On 2 recorded occasions, the barrel was struck by defending fire, and the weapon was destroyed in the operator's hands. Pioneers move forward. That is their job. The cost of moving forward is paid differently every time. Number 9. The Urban Defense Emplacement version. As the war moved into German cities in 1945, the Krummlauf was adapted for static, defensive use. Instead of being carried and fired by a moving soldier, it was fixed to a mounting bracket embedded in rubble or bolted to a window frame. The operator could fire it remotely using an extended trigger cable, remaining behind solid cover while the weapon covered an approach lane. This version was not factory built. It was assembled in the field using salvaged mounting hardware. There was no regulation that directly addressed this configuration. It violated the spirit of weapon handling standards and created accountability problems for ammunition expenditure. Men defending positions they knew would eventually fall improvised systems that allowed them to fire without dying in the first exchange. That was the entire calculation. Some defenders used sandbag emplacements to brace the fixed mounting, adjusting angle by repositioning the sandbag stack. Others attached a small mirror at the position entrance to allow the operator to observe the firing lane without entering it. A few positions used 2 Krummlauf units mounted side by side to cover a wider arc from a single protected point. Accounts from the Berlin street fighting in April 1945 describe emplacements of this type on Unter den Linden and in the Tiergarten district, operated by Volkssturm and Hitler Youth units, alongside Wehrmacht holdouts. One defensive position near the Reichstag engaged Soviet infantry for 6 hours. It was destroyed by artillery. The remote trigger cable stretched and lost tension after repeated firing. Operators lost the ability to fire without re-entering the position to re-tension the mechanism. A fixed position in a losing defense is not a strong point. It is a monument to the decision not to retreat. Number 10. The final prototype, the mirror rifle. The last experimental variant documented in Wehrmacht ordnance records was not a bent barrel system. It was a mirror-based aiming device attached to a standard rifle, allowing a soldier lying flat behind cover to aim and fire using a reflected image of the target. The weapon itself remained horizontal and below the cover line. The mirror assembly extended above it. It was tested by a small team at the Spandau Arsenal in early 1945. The project had no formal designation. It was categorized internally as a feasibility exercise. No production order was ever issued. Ordnance researchers were assigned to evaluate any system that might improve infantry survival in the street fighting consuming German cities. The mirror rifle was one of several such proposals reviewed in the final months. Some researchers proposed using optical glass from rangefinders already in Wehrmacht inventory to improve the mirror assembly's resolution. Others tested the system with multiple rifle types to identify the best base weapon for the concept. A few technicians extended the mirror arm to allow firing from behind walls rather than only from prone position. One test report describes a shooter successfully engaging a target at 80 meters using the mirror system in 3 out of 5 attempts. The system was also tested at night using a small electric lamp to illuminate the mirror. The results were not recorded as satisfactory. The mirror distorted the sight picture at angles beyond 15 degrees. Accuracy dropped to unusable levels past 60 meters. The assembly added bulk that made movement through rubble difficult. The last weapons developed in a losing war are often the most inventive. They are also the ones that arrive too late to matter.